Hi all and welcome to Stick Money, where we're going to discuss all things related to finance. And in today's episode, we're going to learn an important tool for any investment professional, which is asset allocation by mean variance optimization. You're going to learn how to do mean variance optimization, you're going to plot the efficient frontier, and you're going to decide how much to allocate to each of our free funds within our free fund portfolio. Simple. So before I go into learning outcomes and the assumptions on yourself, I had a recent conversation with an investment professional who said to me, not many people will do a mean variance optimization, hence this video. But in my experience, I haven't come across many individuals that can't do a mean variance optimization. The only individuals I've met that can't do this are first year undergraduates at university that are studying finance, interns, and graduates that have a non-investment related field. So if you're one of these and you want to learn how to do mean variance optimization, plot the efficient frontier, and decide how to allocate to each of your free funds in your free fund portfolio, this is a video for you. But what I'd be interested in though is, from your experience, whether you think the few or the many can do a mean variance optimization. I think it's the many, but I could be wrong, so I'd be interested to know myself. And also this video is useful for myself. I haven't done this in 10 years, or probably more than 10 years, and it's good to shake off the rust and actually do some of the calculations. So let's go into learning outcomes. My assumption on yourself is you have some basic Excel skills, okayish good skills, and you have an understanding of mean variance, because I'm not going into great detail here. I'm not going to go for the maths, the proofs in detail. I'm not going to go through the pitfalls and so forth of mean variance. What I encourage you to do is read the journals or the papers on this. It's very interesting reading, and it will expand your knowledge. So let's go to the key learning outcomes. Is you're going to learn how to calculate the inputs of a mean variance optimization. You're going to use Excel solver to plot the efficient frontier, and then we're just going to wrap this video up with some final thoughts. So let's get into this. The first thing you're going to need is some returns. Whether you go online, download stock returns, bond returns and so forth, it's up to you, or you find fund returns, but here they are. These are mine, all fictitious, and then you copy them, and then you'll just paste them in here. So the key calculation we're going to do are these basic stats here, the variance covariance matrix here, and we're also going to calculate the correlation matrix. I thought it'd be nice to do this, but you don't need it. And the correlation matrix is a standardization of the covariance matrix. It's much easier to interpret because it bounds everything from -1 to 1, and therefore easier to interpret the relation between the funds here, or the securities, or the asset classes. So without further ado, let's start getting into some calculations. So the first thing we're going to do is calculate the average monthly return. So for fund 1, we go equal average. Then we're going to select a fund 1 monthly return array. I'm just going to fix the rows here so I can drag it across, and we get an average monthly return of 1.6. You'll drag it across. So for fund 5, you can see this is what the calculation is. Next thing is we're going to calculate the variance. So equals var.s. And again, you're going to select fund 1 monthly return array. And then just do $signs to fix the row so you can drag it across easily. And that is the variance of fund 1. And drag across, you get the variance of all the other funds. Now, the next thing you do is calculate the standard deviation. There are two ways to do this. One is to use the formula SDDEV.S, open the bracket, and then you take the Fund 1 monthly return array, and then you just drag it across to calculate the valuation for all the other funds. Now you could do the square root of the variance, which equals the standard deviation, and you'll get the same answer. See, for Fund 1 it's 4.7, it's 4.7, they match up. So the number of periods, we're going to use a formula called equal counter, and then we're going to select Fund 1 monthly return array, and we get 60 periods or 5 years of returns. So voila, we calculate these basic stats. Next thing we need to do is calculate the variance covariance matrix. Before we do that, we need to calculate the monthly excess returns, and that's simply equals, you take the first or whatever fund, one of the Fund 1 monthly returns, and then you minus the average monthly return. So just fix that there. So let's do an example, a few examples. 3.5 minus 1.6 equals 1.9, minus 10.5 minus 1.6 is 12.1, and again here minus 2.5 minus 1.6 is 4, minus 4. Just going to repeat this so you get the picture, and we'll just check this formula is the fixing is correct. So yes, 2.4 minus 1 is 1.4, 7.2 minus 1 is 6.1. So now we've calculated the excess monthly returns for all of the funds. Next thing to do is use this formula, covariance.s, open bracket, and then you do a fund array, and then you put another fund array. This can be quite tedious because we're going to have to do this 6 times with some fixing of some of the columns and rows to drag them across. But it'd be interesting to know how long this takes, but it is time consuming. But I'll show you an alternative method in a second. So let's get this underway. So you put equal covariance.s, open bracket, you take a Fund 1 monthly excess return array. Let's just fix that, and then you'll take a Fund 1 excess monthly return array, and we're just gonna fix the rows here so we can drag it across. Now the interesting thing here is the covariance between Fund 1 and Fund 1 or itself is the variance, so this is a good check. So you can come here, check your variance, and then look at your variance covariance matrix and check here the covariance between Fund 1 and 1 is the same, and that's a good check to do. Okay, so let's drag that across. I'm going to choose this formula. Now I'm just going to paste this in, and then what I'm going to do is I'm going to change the first array to Fund 2 here, which is column L. So you'll see underneath here, this will red outline here or array will appear. So Fund 2 is fixed, and the Fund 1 array, which is in red, will then just skip, move across as we copy and paste this across here. And again, we can check the covariance between Fund 2 and 2, which is the variance, equals the variance over here. Yes. So I'm just going to drag this formula on. I'm not going to go through this, but I'm just going to change this first array, so L, and then change it to M, and so forth. So let's do this. M, and then we're on the Fund 4, which is in column N. Fund 5 is is in column O, so we'll change the L to the O here, and then the final one we'll just change it to P. So, voila, you've now created the variance covariance matrix. I think that took me, sadly it took me I think a couple of minutes. So a simple way is just to use this formula here. So, and it's effectively doing the same thing as what we did with the covariance.s here, but we're using matrix multiplication. So we're multiplying the covariance, we're doing mmult, and basically we're multiplying the transpose of the excess monthly return array with the excess monthly return array, and then dividing by m periods minus 1, which is effectively what we did up here, but just using the covariance.s formula. But you'll see, let's see how long it takes us. So let's do this. So you select the area, and then you go equal mmult, and then you'll transpose the excess monthly return array, which is all these, and then you'll times it by the monthly excess return array. Apologies, I've done a mistake here. I didn't control. You need to Control Shift Enter. Apologies. So you got mmult. Oh, I definitely have some ring rust here. Oh, and I didn't divide it by. See, you just got to. But you're just always thinking. So yeah, there you go. And as you can see, the variances are all down here, and all on the outside you got all the covariances. So that took a little bit longer than expected because I marked up the formula, but it should just take you seconds. But I've got a bit of ring rust, so you know, butterfingers. Now we're going to do the correlation, and you're just going to use this formula. So you do correl, you take the monthly returns here, not the excess monthly returns, but the monthly returns, and what you'll do is you'll take the first array is the fund fund 1 returns, and then it's on itself. And I'm just going to fix here both the columns and the rows, and then just fix the rows here, so then it gets to move across as we go along, and you'll see that. So let's do this. So, and obviously this is going to be 1 because the correlation between 1 and 1 or itself is going to be 1. So let's just copy this formula here, bring it here, track this down, and now we're going to change. So here we'll change it to D, because that's for fund 2, the monthly returns are in D. Oh, CD. Butterfingers here. E for fund 3, F for fund 4, change it to G for fund 5, and then H. As you see, we're just, changing the corral and fixing H here to ensure this always stays still, but then the next array, which is fund 1 here, that starts to jump across as we do it. So this will just allow us to do a simple drag it across. And voila, you've got your correlation matrix. There is a simpler way which you can do. So it's this formula here. And what this formula is doing is basically the same here, but effectively what it's doing is the correlation between say fund A and B is the covariance of A and B divided by the standard deviation of A times standard deviation of B. And this is what this formula is doing. So if you select here and you type in, you select equals, you select the variance covariance matrix, then you're going to divide by mmult, or matrix multiplication of the transpose of the standard deviations times the standard deviations, and that will give you your correlation matrix, and it just comes out pretty quickly. So instead of using Corel, if you've got lots of funds or securities or asset classes, just do this formula and you'll get it out quickly. So we've done all the calculations now. We're going to the output tab, and then we'll create these interesting charts. So let's start plotting the efficient frontier. So here is effectively I'm just using the annualized expected return. So effectively how to do this, I'm just dragging in the return using a formula called offset of fund 1, and then I'm times it by 12. So monthly return, you just times it by 12. For the annualized standard deviation, I brought in that, and then you're going to times it by the square root of 12 if it's monthly returns. So variance I've left monthly, and then I've introduced the Sharpe ratio, which is just the annualized return minus the risk-free rate, which is 2% we decided here, and then we're dividing it by the annualized standard deviation to give the Sharpe ratio. We've just dragged in the end periods, and we've inputted 2% as our risk-free. And all here is the variance covariance matrix. We just dragged it in, and we've dragged in the correlation matrix. So let's calculate a number of things. So the next tab we're going to look at, the next thing we're doing is creating some output. So we're going to calculate portfolio, a return, risk, Sharpe ratio, and let's just put a third. In each of these funds for now. So to calculate the portfolio return, this is simply, you can use a formula called sum product, which you're going to put the first array as the weights, and the second array as the returns. And effectively what this is doing is saying a third times 18.6, a third times 9.9 plus a third times 9.5. So it's just a weighted return here. So that's simple enough, but you can just use the thing sum product. Standard deviation is a bit more complex, but we're using this formula here. So let's work this out. So what we're doing is we're doing a matrix multiplication here. So mmult, we've got the weights, and then we're going to times it by the variance covariance matrix, and then we're going to do another matrix multiplication. We're going to times that by the transpose of the weights. That will give us the variance of this part here is giving us the variance of the portfolio. We square root it to give us the monthly standard deviation, and then we're going to times it by the square root of 12 to annualize it, and you come out with this number. And again, we did the chart, but again, it will just be the portfolio expected return minus the risk-free rate divided by the risk of the portfolio, or annualized standard deviation in our case. And then I put in these weights and the total weight, and this will become a bit more clearer while putting these numbers in. It feeds these calculations, but also it will help when we're plotting the efficient frontier. So, so the first thing we need to do is we need to calculate the bounds of the standard deviation or the risk. So we need to look at the minimum risk and the maximum risk. The maximum risk we know is going to be one of our free funds, the maximum, which is 16.4. Hopefully this is intuitive, but we're not going to do any short selling or so forth. It's always going to be, have to have a positive weight. So the maximum risk you can have is investing in 100% of the riskiest fund. But let's look at the minimum risk. But unfortunately, when I recorded this earlier, we could not do, wouldn't record when we did the solver. So I've got this thing here to show what we're going to be doing, but you go to the data tab up here, and here will be solver, but for some reason when I recorded it you couldn't see what it was doing. But what we're going to do is, if you can see here, we're going to put in something. So you press add here, and then you're going to make some constraints. So we put N4, it's got to be equal or greater to 0, and then for N4 we put that equal to greater to 0, and also O4 is equal to 0. So all the fund weights have to be 0 or greater than 0. Well, they have to be equal or greater than 0. And then we put another constraint here where we say, okay, so P4, the total weight, has to equal to 100. And then to find the minimum risk, we put K4, which is the standard deviation or risk here, and we want to minimize it. And then we press solve. So let's do that right now. Unfortunately, I don't think you can see it on your screen, but I'm just going to do some. So you'll keep the solver output, and that will be your minimum. So it's 9.6. I'll paste it in here. And what I am doing, I'll just get rid of that and put that over here. And as you can see, we're going to do some max Sharpe and the max return for a given level of risk. It's effectively what I'm doing here is you set, so you can paste all this in, which I've already done, but you'll get all this. You'll paste this in here. So you copy this, and then you'll paste this in here. And then the next thing I'm going to do is, you then want to go equals this plus the increments. So I've just basically the increments are in 10. Fix those increments until you get to, oh, in my case it's a bit different, but and you basically add in the increments. Okay, let's do that. Let's delete all this. It might be a longer video. This is going to be too long a video. So basically, you're gonna. I've done the increments here. and then you add 0.7 to each of these as you go along. And then what you're going to do in Solver is you can add some things in. So let's go across here. I'm going to take these two things. So you're going to add an extra constraint here, if you can see it, which is to put so you add here, you add a constraint, this will come up, and then you'll select K4, and then you'll put it to equal to a specific portfolio risk. So let's do 9.6 again. You press OK, and that will be it. And then also you'll change this objective to the return, and you put the max. So what we're doing is setting the portfolio risk or standard deviation, and then saying for that given level of risk, give me the maximum return. So I will just do that, but you won't be able to see it, unfortunately, I think, because this video, for some reason, it doesn't record it. But I'll just do it quickly. And there you go. And then you'll repeat this process. You won't be able to see the solver, but you're just effectively opening solver again, and then, which I'll show you, let's close this over here, and then you're just clicking on this and you're changing it, and then you're equaling that to a certain number. I've just spotted here, this is a mistake. When I was doing a screenshot of it, it should be equal to a certain number. So this is correct here. So your standard deviation is equal to 9.6. And then you'll just change that to the next one, which will be, I think, 10.3. And you'll keep doing that. So let's do it. But unfortunately, it doesn't show on your screen. So we'll change. I'm just going to change it to 10.3. And then solve for it. And then all these numbers are going to change. So basically it's going to change all this, make sure that equals to 1, and that they're all greater than 0 here. And then it will give you all these returns. So I've done all the calculations. But you just, keep going through the whole thing. So you've done that, and that gives basically your efficient frontier. But what will be interesting is we want to maximize the Sharpe ratio, or the return per unit of risk, and that requires you to change the solver. So you go to data again, up here to your solver, and you get this screen. And then what you're going to do is you're going to delete where you put the specific portfolio risk. So when it was like 9.6, or when you ended, you probably had 15.9 or 16.4. You'll delete that, and also then you would set the objective to the Sharpe ratio, so L4, and you'll maximize that. So let's do that in but I don't think you can see it on the screen. But let me do that. That will change the numbers. and then to maximize your chart, this is what you're going to get. Let me move that out of the way so we can see this clearer. So this is the numbers you'll get. I've already done it. Let's double check if that's right. Okay, maybe I need to. That's right. Yes, it's just water. And then we are just gonna, instead of doing the this allocation, we're just gonna round these numbers because no one really invests 61.4 does an allocation like detailed. You just round the numbers up generally. So this is how we produce the charts. So here you're just gonna make a chart, and that's a scatter plot of it, and then you're just gonna select these two, and that's your efficient frontier. Interestingly, you can do here, which is effectively your prelim portfolio, and this is the allocation for a prelim portfolio, which is here. So 60% to fund 1, 35% to fund 2, 3% to fund 3. And as you can see, this chart here is just showing you again, we are just taking all these asset allocations and put them on the board. So, for your first allocation for a certain risk level, which is your global minimum variance portfolio, which is the minimum risk for the portfolio, is 9.6. And then you got 1, which is then 10.3, and a return of 12.1. That is the allocation you have, and so forth. You go across. And what we've decided is very simple. We've tried to maximize the chart, and then we've just rounded the figures to say we want 62% to fund 1, 35% to fund 2, and 3% to fund. So 2%. So for fund 1, 62%, fund 2, 35%, and fund 3, 3%. And that's pretty simple. I think you can quickly do that. And now I would suggest you just have some fun. So you could do like 4, 6, and then just repeat the process. Create a new chart and play around with it. Put new fund returns in this. Change. You got fund 1 return here. Invert these. So they're like, this is a positive 7.3, negative 3.5. So you have a complete negative correlation of 1, and then see how this plays out in your mean variance optimization and your efficient frontier. How it plays out here, how it changes allocation. You'll see the effects of doing these things. But this comes to the end of the video, and let's just do a quick final wrap up. So my final thoughts here are quite simple. Is what we've done here is use some science for asset allocation. The missing part here is the art of asset allocation. The science is quite easy to do, and this is just one part of the science, doing a mean variance optimization of asset allocation. It's easy to learn, easy to do, but an important part I think many people oversee is the art of asset allocation. We're not going to go into it, but once you can master these scientific things, the science of it, don't overlook the art, because I think a lot of people overlook the art. They just use the numbers, churn out the thing, and go, wow, you should allocate this and that. But there's an art to this, because you don't know the future, and it's all about using the art to predict or what you think the future will be, to put in a robust portfolio together and a robust asset allocation. to achieve your goals at the end of it. And there are many other things to consider, such as liquidity and so forth, within this. But this wraps up the video. I hope you enjoyed it. And I hope what you can do is you can do a mean variance optimization, you can do an efficient plot of efficient frontier. And if you like the video, please like it, and add all those comments in. If you don't understand anything, please just put the comments in and I'll answer the best I can. Wishing you a great day, and thank you for watching.